All right, 13, we have a quotient rule. G of x, e to the x over 3x squared plus 4. And so, again, quotient rule, we'll do low, which is the bottom, times the derivative of the top. Derivative of e to the x is just e to the x, minus the top, times the derivative of the bottom. So you'll do 2 times 3, which will give you 6x, and then derivative of 4 will be 0. So low d high minus high d low, all over the bottom squared, or low squared. And we don't actually have to FOIL this out, we'll just leave it like so. And then if we want to simplify a little bit further, we'll get 3x squared plus 4 minus 6x, and I'm factoring out the e to the x from both out here so it can combine like terms. There are no like terms, so we'll end up with a quadratic here, times e to the x, and then over this, over 3x squared plus 4 squared. So I'll rearrange this when I type it in, but we'll have e to the x, and we'll have a 3x squared minus 6x plus 4. If I put it in standard form, x plus 4 over 14, we're going to find the derivative, so we'll use just the sum of the derivatives. Have 3x squared plus 5 divided by x squared, sorry, not x squared, x to the 7th. So instead of doing quotient rule, I'll write this as a negative exponent and then go back and change it later. So what I'm looking at is, well, not yet, not the derivative yet. I'm going to write this as 5 times x to the negative 7th power. So I can just use the standard power rule. So 2 times 3 will give us 6x, subtract 1, just 6x. And then a negative 7 times 5 will give us a minus 35x, subtract 1, so it gives us a negative 8. And then I can make this negative exponent positive by moving it to the bottom. So we'll have 6x minus 35 divided by x to the 8th. And so that's a better way of doing it. You don't have to do the quotient rule here. You can use the power rule.